Hello everyone, let's talk about creating objects. Now, a variable can hold either a primitive value or a reference to an object. For example, we can declare a variable title as an object reference, and the class of this object is string. And you would be wondering, why is it that a variable cannot hold an object directly? And the reason is actually objects can be very large or very small, and what is more important, they can be dynamic. That is when the objects change in size in many ways during the execution. For example, think of a list. List is an object, and a list can begin its life as an empty list, and then somebody can add 10,000 items to it. And it would be much better to have a variable holding just a reference to that list, and this list is handled somewhere in the memory. So besides the word reference, we will use address of an object, that is where it is in the memory, or we will use an expression pointer. So address is really pointing to something. We use new operator to create an object. Here is an example of creating a new string. So title is a variable. It was declared on the previous page, so that was a declaration. And this is an assignment. So title is assigned to be a new instance of string with this sequence of characters as a parameter, as an argument. And it's called instantiation. This is an instance. Title holds a reference to an instance of a string class. Now, full disclosure, string is a little bit unusual as a class, and it has some behaviors that make it look a lot more like a primitive type. But that's just for convenience, and we'll explore that a little bit later. Now, once you have created an object comes with methods. For example, a string object comes with method length, counting the number of characters in it. Or a method, println, of an object system.out is printing. This is an object from the scanner class, apparently, and it has a method nextInt, which we call to take the next input from the user. So some methods can return a value, and some can change the state of the object for many cases. Now, it's very, very important for you to remember this diagram. If we talked about a primitive type, num1 is an integer, it actually directly holds the value. Whereas in case of an object, name1 holds a reference to this object. In other words, a pointer. Alright, so let us look at this example. So name1 contains a reference to a string Steve Jobs. That's actually an object where this sequence of characters is held. And name2 contains a reference to another co-founder of Apple. And we decided to say that name2 equals to name1. That is Java code. And after that, name1 is actually passed into the value of name1 is passed into name2. That is, name1 and name2 now have the same reference. They refer to the same object. And contrast that with the case when the variables, the primitive type, hold primitive types directly, like 38 and 96, and after we say num2 equals to num1, the value in num1 will be assigned to be also a value in num2, but those are two copies of number 38. Now let us go back and talk about the aliases. After we reassign num2 equals to num1, those are both aliases for the same object. And we can call either of these aliases dot do something to this object, and that will be done because they actually refer to the same object. Now, aliases can be useful, but you should be very careful because it's harder and harder to track them. And remember, if you reassigned a name to a different value and there is no other variable pointing to that object, then this object is garbage collected. For example, once name2 was reassigned to be the same as name1, the object string Steve Wozniak would be garbage collected as long as there are no other aliases pointing to it. In which case, of course, it will stay. The reason is if something has no way to be referenced to, it's completely useful for any practical purpose. So once it's losing the variable pointer, it's no longer, it can be no longer found. All right, and before we move to string class, let me actually show you my little prepared program. You really don't need to know how the lamp class was defined. Basically, there is one hidden variable which takes values true or false, that is lamp on or off. But you need to concentrate on the way how to use this in your code. So I want to instantiate two lamps. I'm gonna say that lamp equals to lamp1, lamp2. So I declared two lamps, and originally lamp1 equals to new lamp, and lamp2 equals to new lamp. So I created two distinct lamps, which I know because I called the new keyword on the lamp constructor. Really, I called the lamp constructor every time. There are no parameters for this lamp. We can check that lamp1, what methods are there, is light on, that's a method, and toggle switch, those are kind of custom methods. By default, the light is off for both of them. And we want to check that before proceeding. Let's see. It is false that the light is on, so this is really the value of this Boolean variable included in the printing statement. That's all it does. Now let's toggle one of the lamps. Let's toggle lamp1 dot toggle switch, and now lamp1 dot is light on. And since we already checked that the lights are originally off, that's how I designed the lamp, I'm going to comment out this code, Ctrl+/, and try again. So it's true that the light is on. So now my lamp1 is light on, and lamp2 is light off. Now let me now say lamp2 equals to lamp1. And now we check the light on lamp2. It should be on as well. Bear with me for a moment. Yes. So now lamp 1 and lamp 2 are holding the same reference. And now let me toggle the light for lamp 2, for example, and then check the value for lamp 1. Toggle switch, and check the value for lamp 1. Is light on? After I toggled the switch for the lamp 2, the lamp 1 light should be off. So see the last printing statement? The last statement is light on was off. I toggled the switch for lamp 2, but for lamp 1 it is now off as well because they reference the same object.